Hi, so happy to see so many people, so many familiar faces, but also new faces. So I'm very glad to be here. I was told to stay on the X. So if you see me going to the light, do this, and I will go right. If you see me going to the red, do that, and I will come back to my X. So I need to stay here to fit into the camera. So as I said, I'm super happy to have you here, even on a fourth day of reInvent. I'm sure you have a brain overflow. You heard so many interesting sessions, but having you here is a good sign. It means the topic we are going to present you is relevant for you, and we will make sure that you will leave the room with more information, with use cases, with anecdotes, with data, which you can use in your journey. So have fun. Try to stay with us in the next maximum 60 minutes. So have fun. I have the pleasure to have two guests with me. And the first one is Thomas Birwirth from the Volkswagen Group. He's a senior vice president for the IT, production, and logistics. Thomas has a background of over 20 years in automotive and digitalization. He's a very experienced guy. He did his PhD in mechanical engineering and in computer science. He also launched several products during his journey at the Volkswagen Group. Before that, he was at SAP and also launched there several products for logistics and digitalization. So as you can see, he's very knowledgeable. And I'm so glad to have him here with us today to share his experience with us. We have also Verena Kustovagelis with us. She has been with AWS for approximately 2 years, and if you think that that's not a long time, I can tell you we are joking about the time at AWS. We say that the first year we calculate the years in dog years. So we say the first year counts 15 human years, and the second year counts 9 human years. So that means Verena is with AWS, if you count in human years, for 24 years. And that's why she's also happy to share with us a use case which she developed as a customer solution manager with Volkswagen. And then last but not least, it's myself. I'm in charge of the tech strategy for auto and manufacturing. I'm with AWS for 2.5 years approximately. I'm a passionate industry person. I have been in various industries, in Nokia, Telco, in Conti, Tier 1s. So I have a passion for anything which can make life safer and more comfortable. And I am the moderator today, so you will see most of the time Thomas and Verena on stage. Maybe just a couple of data as the beginning. At the beginning, you know, Amazon is a data-based company, a data-oriented company. So I'm not sure if you have heard before that approximately 68% of manufacturers have started their journey of digitalization, or they are just about to start it in the next couple of months. But only less than 30% of them are already convinced and see the business value of this transformation. And over 40% of the manufacturers stuck in the pilot purgatory. They are still figuring it out. They are still fighting with integration challenges. So as you can see, and I'm sure this is what you experience, it's not a trivial transformation. If it would be easy, everyone could do it. It would be just like that. But there is a certain complexity behind. You need to be super convinced. You need to be also super diligent about what you are doing and when you are doing it. Your manager needs to support you. So it's an interesting journey, and I'm super happy to welcome now Thomas on stage to start presenting the Volkswagen Group journey. Thank you, Thomas.
Thank you, Andrea. Hi. Oh, wow. There's a lot of light here. Yeah, okay, so as we tried to say what we're telling you today about our digital transformation story, I thought, okay, let's talk first about our enterprise. And then we thought, okay, the typical KPIs, I think that's a little bit boring. So we should not tell you that we have 65,000 plus employees, that we have 13 brands. We should not tell you that we have more than 114 facilities in the world and making also 320 billion revenue. We would like to demonstrate a little bit out of our portfolio. And what we brought today is the next launches, what we have, and you see all these beautiful products upcoming. I mean, right here in the United States, you probably need, the Atlas and the Tiguan, but we have other very emotional products like the VW Golf, maybe you know the GTI. Of course, we have our full electrical family with the ID family, and probably you saw the launch of the ID bus also in the United States. And there's a lot of more products, and I will not, make a, product roadmap of VW out of it. Last to mention, only Scout coming up in the United States as a full electric vehicle. We'll have then a pickup and an SUV coming soon, and very excited about it. The point is, when you see that slide, there's two portfolios. So if you look a little bit closer to it, this is one dimension what we have as a classical car maker right now. Our portfolio is already divided in combustion cars and full electrical cars. Of course, there are now combinations in the middle of hybrids, but we have to operate, meanwhile, two types of cars. And for example, here in our plant in Chattanooga in Tennessee, there's also being combustion and electric cars built on the same assembly line. What this means on a side of complexity, we will come to that. There's two trends, or let's say at least three technical trends. One is digitalization, and the second is autonomous and electric. I talked already a little bit about electric, but those two trends are coming very close together. And I mean, everybody was a smartphone. I mean, this is a remote control, but think about this is a smartphone. Then you are in touch with your personal device, with your electrical car. For example, I, as a driver of an electrical car, I plan my trip with a smartphone. I look where I have my next charging station. I can send commands to my car. I can say, no, I want to have a cooling of the car. So that means digital, coming out of the space of IoT, has a strong influence on the product. And that means the car itself is an IoT device at the end of the day. So you're having an IoT device being in, let's say, communication with your car, which is another one. And now it's getting even more complex. Let's say a car, an electrical car, let's say has a lot of ECUs, TCUs inside, which are all, let's say, IoT devices. For example, if you're sending a command to your car and saying, hey, set me the temperature to 75 degrees, then the command goes over the cloud, let's say over the air to the car. It's received by a connectivity unit and going then to a computer that controls your temperature on the car. And now it's getting even more fun because when you think about logistics and production, then you have the situation that you have an IoT device consisting of a lot of IT devices being built by IoT devices. Because in our factories, meanwhile, let's say also the machineries, the robots, they're getting all intelligent. They're connected to the network, or they're getting software updates. When you want to build a combustion and electrical car, you have to update, let's say, the machines within a cycle. For example, producing electrical and, let's say, combustion cars on the same line. And with these two trends, automatically you're coming to data. Because at the end of the day, it's an exchange of data. So you need connectivity. This is the first thing what you have to establish. Then it is about read and write of data, consuming data, processing data, having applications, doing something with data, and sending data back. So data, digitalization, electric is very, very close to each other. And this is so more or less the technical stuff out of it. And now comes another trend, which is resiliency and supply chains. I mean, since COVID, we all know what, let's say, how many disruption we can have if, let's say, the daily life is disrupted by such kind of a disease. And you can imagine that a car maker, and a car consists of more or less 2,000 parts. And all those parts have to come together, let's say, in a final assembly. And you can imagine how much stress logistics have if a part is being blocked on whatever reason. And moreover, there's more crisis in the world. There's more diseases in the world. There's more other interruptions, and you need now a very high confidence of your supply chain. And the supply chain is linked to your production, and the production is linked to your customer. And this is where we thought, okay, what can we do to build smart applications, and what is the setup to deal with it? Yeah, and finally, sustainability. This is, let's say, a super important thing for us as a car maker, because we want to go carbon dioxide neutral, and we're doing a lot of stuff to reduce that footprint. And maybe some of you guys were yesterday in our session together with Jörn and Maya and the guys, and presented how we reduced also using those platforms and patterns, reducing then our footprint in electrical consumption, and finally then carbon dioxide. Yeah, and globalization, I mean, I don't have to mention it. There's a lot of smart teams around the world, and we have corporations, let's say, with a lot of them. And of course, we want to use this knowledge for building global products. So what is now our process, and what is the landscape? To educate you a little bit about it, so we thought, okay, we have generally 3 dimensions in it. One is the process itself. I think most of you know the basic automotive process. Everything starts with a customer order. Then after you have the customer order, you have to see all the components, the parts, everything what you need, and which kind of facility should it being built. You want to tell the customer a delivery date, so this has to be scheduled. Then you have the basic process itself. And finally, once the car is being built, then starts another shipping process, because the assembly place is in most cases not the place where the customer lives. On the other hand, there's a lot of systems now engaged. For example, when you want to do operations, when you want to run a plant, then you have to make a very detailed plan. So you need to know which person and which cycle time is doing exactly what. And you need to make a detailed planning on it. And on the other side, you need to be flexible by production control systems. If you have any change in supply chain, in order sequence of customers, you need to be flexible and to change it in the control system. Warehouse management is always a big topic for logistics. On the one hand, you want to have resilient supply chains, which means a lot of stuff in the warehouse. On the other hand, you have your controller that tells you, nope, everything in the warehouse is wasted money. Keep it as a minimum, and you have always this kind of trade-off. The last big thing I want to mention, and maybe you don't know it, the main devices we have in the cars, ECUs and TCUs, and there's probably 5, 6 very important ones. They have meanwhile more lines of code, and it's about 30 million lines of code each of them. So let's say the vehicles nowadays, right now, it's not any longer a piece of metal. It's IoT devices with code, and you have to manage this software even during production. So that means you need also a process how, while you have production, you can do configuration of the vehicle. So the last dimension is the data. So this is now crossed by everything. So logistics is connected to capacity management. This is connected to vehicle configuration. This is connected to human workplace planning, and everything is connected to anything. And this was our starting point, where we said, okay, when we build the applications of the future, how to do that? How to do modernization, how to run it, how to build, let's say, new kind of applications, how to engage for AI and that kind of stuff. And so together with AWS, we said, okay, let's have a partnership, which is now running since 5 years. And we, as a classical automotive company, we said, okay, let's bring our knowledge in about, let's say, how to build a car, how to produce a car, owning all those processes, and then let's have the help of one of the bigger tech players in the world. And so Verena will tell us now what was and what is the engagement of AWS in that partnership.
Yes, so besides being the cloud provider for VW and providing them with our cloud services, we have also collaborated with VW heavily in the last 5 years, where we have shown them how to scale cloud solutions globally. We engaged with several plans of them in order to build cloud solutions, the so-called use cases. And according to our leadership principle in Think Big, we were always driven by innovation and tried to drive innovation as fast as we could. So we also showed VW how to use cloud as an enabler and how to use cloud as driver for innovation. And Thomas will show you now what we have actually built in the last 5 years.
Don't worry, she will come back. So just one slide more, and then Verena will show some of those use cases. First of all, I will tell something about what is the strategy about the cloud itself, and then we're going step by step more in the detail how this on a technical base is looking like. Here we go. The basic principle is on that slide. So it's a 3-layer picture, what we brought with us. And in the main base layer, what you see on the bottom, this is our connectivity and data layer. And we build it in this shape, how to call it, I don't know. Because there's a very broad layer on the bottom, because we had a lot of protocols and a lot of integration stuff. So think about it, there's new plans, there's older plans, there's new technology, there's old technology. And so that means you have a lot of integration work to those different elements and devices. So the top-bottom activity in the especially shop floor area is how to get everything, first of all, connected, and how to write all the protocols so that you can get the data out. And once you are done with this session, then you're getting the next important question, how to make an interpretation out of it. So if you have the data of a machine in, I don't know, let's say Chattanooga, and you want to compare it with a similar or same machine sitting in Wolfsburg or Mexico or somewhere else, and you're looking to a specific value as a developer, and you say, hey, give me mean time to repair or give me mean time to failure. How can you make sure that those values are really the same values? So that means you need another layer where you have a kind of harmonization of this data. And this is sometimes really hard work, and still we're working on it to get this in an, let's say, automated, because you don't want to enter this all manually and doing this in a cross-check. So this is a really intensive work to get this first layer done. In the middle layer, we said, okay, we need now a layer where we have general enablers in it. What is an enabler? This is a typical get functions. Get me a position, get me data, get me something. Where we said, okay, when I'm an application developer, I would like to have a first set of applications, what I can use, so that they're not all over the place have to write the same code. So I would like to have connectivity and my first functionalities, enabling functionalities of the platform. And as a developer, I would not like to write all this kind of code. And then finally, you have a last layer, and in this last layer, then you have all the applications bringing value to the customers using it. And this value apps is very important because that makes then the cost efficiency. You see then really bringing value, and one of those value apps we want to talk in a detail, and I hand back to Verena showing us one of those applications.
Yeah, thank you, Thomas. I guess you're already very excited to see the use case, but before we're coming to the use case, we'll reflect a bit on 2021. So for the ones that have been to reInvent in 2021, should have been remotely, we had a presentation on our first industrial computer vision use case on DPP, which was the intelligent sign inspection use case, in short, EASY. And back then, EASY was built upon Vision Workbench service. And as you see in the picture, it's an easy use case. So you have your mobile device in your hand, You scan the label on the vehicle, and then you get directly a feedback of several information. And you see directly if the label or sign is put correctly on the vehicle. And you can imagine, especially when it's written in another language you don't know, it's kind of hard to read through it. So therefore, very helpful and very fastening up the process. And as it was a great use case, we wanted to scale it across several other brands and plants. So what we figured out with Vision Workbench was kind of hard because you always needed to start from scratch again. And that's why another team at VW, which is Uwe's team, is the Software Development Center in Dresden. They have built a fully cloud-based solution, which is Iris Core. And Iris Core is there for image evaluation using AI models. And you see here a very, very high-level architecture. So you see from the top, you have a request going to Iris Core, which is basically image data, going through Amazon SQS. Amazon SQS is our simple queue service, which is there for queuing, a fully managed queuing service for serverless application and microservices. And then from the other side, you see the AI model upload, which is done through an AI model deployment API. And then it's brought together into Iris Core. Iris Core evaluates the data and sends back a response either to SQS or to an Amazon S3 bucket. And in 2024, we really focused on rolling out Iris Core into several plans. And you see here in the picture that Iris Core consists actually of two elements. So you have the Iris Core, which is centrally developed and orchestrated, and you have the integration layer in order to establish connectivity between the shop floor and the cloud. And in 2025, we will be focusing on developing Iris Core further, so meaning implementing new features to it, also continuing with the rollout into other plans, and for sure, building more use cases with Iris Core. And now, coming to the actual use case, which was built in 2024 as well, with Iris Core, which is the wheels object detection use case. And therefore, our AWS professional services, they collaborated with a VW team, and they took a particular plant in order to rebuild the use case, because the use case was already running, but fully on-premise and on one single server. Therefore, they are facing challenges like missing high availability, missing scalability, and also the operational effort was kind of high for the team. So that's why the team thought of, hey, let's rebuild this use case, maybe fully in the cloud. And you see on the picture is really about detecting wheels. So you have cameras installed at the shop floor that are capturing images of the wheels. This image data is aggregated, pushed to the cloud, to the Iris Core service. Then Iris Core checks if the 4 wheels have the correct rim and if the correct number of bolts is installed. And then the system sends back an OK or not OK response to the shop floor. And you can imagine you can really use this process not only for wheels detection, but for any kind of object detection you want to have. And when we take a closer look now into the architecture, we will see that also the architecture is kind of reusable for any kind of industrial computer vision use case. So we divided the architecture into 4 different tiers. We have the device, edge, plant, and enterprise tier. And as I said, we have cameras on the shop floor. So we need to establish connectivity between the shop floor and the cloud. And this is done by the DPP connectivity backbone, which is basically an MQTT message broker. So the DPP connectivity backbone service pushes the data from the shop floor into the cloud, in this case into the data hub service, and then the image data is stored in an S3 bucket. And actually, we're having an event-driven architecture here, which means whenever a new image is put into the S3 bucket, the data hub service will create a put notification and will send it via Amazon SNS to the subscribed SQS queue. And for the ones who doesn't know, Amazon SNS is our simple notification service to manage the delivery and sending of messages to subscribed endpoints. And then you see the first box here, capturing images. So we have like a mini workflow starting where we copy and decode the images by using AWS Lambda. And you hopefully know AWS Lambda is our compute service that runs fully serverless code. And then you see also another box here, which aggregates data from the manufacturing execution system. And then both data is brought into workflow check. And basically, the workflow check is using AWS step functions in order to orchestrate the Lambda functions into a workflow. And now, Iris Core comes into place. And as I said, Iris Core consists of two parts. You can see it actually here in the architecture. So we have the Iris integration part. So the image data goes through Iris integration into the Iris Core. Iris Core then evaluates the image data. In this case, Iris Core is using a particular AI model. The team used the opportunity during the implementation of the use case to either train the model further by using Amazon SageMaker. And then Iris Core evaluates the data and sends back a response, again via Lambda and SQS, and stores this into a results table. And we are using here Amazon DynamoDB in order to store the results, which is our serverless, fully managed NoSQL database service. And now we still need to show the results at the shop floor level. So you have someone at the shop floor who's logging into the system via a proxy. The proxy then sends the request to an application load balancer. First, the application load balancer is sending the request to Amazon Cognito user pools in order to make sure that really only authenticated users are accessing the data. And if the authentication has been successful, the application load balancer sends back the request to an Amazon API gateway, and then this accesses the results table in order to show the results as okay or not okay on the display at the shop floor. And you see there has also appeared another box here, which is the emergency strategy. So just in case there is a not okay result showing, the user at the shop floor has the ability to push another button in order to start executing the emergency strategy. And therefore, it updates by having also a mini workflow here, the emergency table accordingly so that you can arrange the wheels and take them out. And yeah, this is an example for a fully serverless architecture that has been built this year with Iris Core. And hopefully, you can imagine now that you can really reuse this kind of architecture for any kind of industrial computer vision use case. And you really leverage all the advantages of using our cloud services, which is high scalability, high availability, and even very cost effective, because this is only running when you start executing it. And this was really the work we have been focusing on the past 5 years, really collaborating with plants, collaborating with our customer, working backwards from the customer, and building these amazing use cases. And we have adjusted our narrative and our North Star narrative last year together with VW. And Thomas will now show you what the adjustments are and what to expect next for the next, hopefully, 5 years of our partnership. Thank you.
Yeah, thanks to Verena. So of course, it's not only one use case what we built. What we want to say to you, there's plenty of use cases what we built in the last years. I would say almost 80 or something, which was coming up, let's say, in the middle layer, in the upper layer, in the application layer. Yeah, now we could say, okay, a good deal, done, let's go home. But the story is not such as easy. So approximately 1 year ago, we said, okay, we have to change the narrative. And the question is, why? Why did we change the narrative? We changed it in a couple of the following reasons. Number one, I think that's still the same. So because when you know the automotive business, especially production and logistics, it's always about efficiency and costs, and you always have to find a way how to make the most efficient way to run your production. But we came to the point, especially in the interchange of the plants, and now having use cases built in plant number 1, for example, in Chattanooga, and getting them back to Poznan or handing over then to Wolfsburg, we saw there is some limits in the data model, limits in the connectivity patterns, limits in the architecture, how it was built. And also we said, yeah, wait a minute, this is not just having all the day fancy use cases. So what about our basic systems, what we have? And there's 20, 25 years plus grown applications, what we have out there. And I mean, a lot of you guys know, okay, when you have really old applications, and on the other hand, you want to have then really high sophisticated AI patterns running on top of it and on the edge technology. This is in the most cases not really working good together. I said, okay, now besides the topic, how can we drive innovations and efficiency by use cases? Let's also push some of our main, let's say, production systems to the same pattern. And let's see that our adoption patterns, what we developed in the last years, that we can, that we're going to reuse them. So let's say we have now the platform, we have connectivity, we have those items. So why not now starting a little bit, let's say, slicing the elephant and bringing now step by step other, let's say, fundamental applications to the same platform space. And the main reason, I think maybe you remember the picture had we in the beginning with those lot of systems and complex processes. You can imagine there's a lot of systems involved. But if you have a new modern microservice-based architecture where you can easily, let's say, communicate between applications and having good standard patterns to your data, then the life of the developer and development of application gets a lot better. And then the usage of data and AI patterns is even more easy than based on old applications. So and then we were sitting together and said, okay, let's look with the architects. How can we do some adjustments in the architecture patterns? And what do we have to do that the exchange of the applications is then getting easier, especially for our customers, the plants. And the basic principle is more reusage. And the really strong principle to abstract the layers. So that means whenever the developer of an application wants to develop an application for production and logistics, or we are carving out of our, let's say, existing applications, has always a solid baseline how to interact, to communicate to the lower levels and to the shop floor level. And here we identified a branch of elements, enablers, what we have to build. And I think this is now one in our next steps of the partnership to enhance here and, let's say, to make this as a solid baseline. The last thing is there's also a lot of innovation coming from the market. I think you saw this here at reInvent. There's a lot of smart ideas. And of course, it's not our intent to say, hey, we have to write any on each application on our own. So if there's smart solutions out in the market, why not having then combinations of using a good smart platform approach, on the other hand, with the SaaS solutions of the market, and let's this combine. So if there's smart solutions out there, why not getting them together with the stuff what we've built on the platform? And of course, we want to leverage and use those elements to drive and to push the things much more smarter forward. Another very interesting element what we have is how to set up the teams. Maybe for a lot of guys of you, I think it's since years clear that you're working in sprints, working agile, and all that stuff. But for automotive industry, that's, I would say, a new pattern. So since a couple of years, we started working agile using, for example, SAFe framework, and trying now to bring features together with teams in an agile way, having the teams interacting with each other, having different products talking to each other. And this was, let's say, also the learning of the last time. We have to connect, to interact with those teams much more stronger. And especially for the phase of our, let's say, older systems, our, let's say, so-called legacy world, we said, what is the highest cost driver, what we have in legacy? And maybe you know it, so when you have bigger systems in production and logistics, you have 50, 100 plants, you're starting in the plant number 1, you're doing your rollout. When you're at 50 or 20, you have to start all over off the scratch, starting at 1 again, because in that second where you're reaching 5, number 1, you have to start again. So it's sometimes very hard, so you need a much more smarter approach, and this is only then by slicing it in more digestible elements, more microservice-based approaches. And our idea is to shrink day by day functionality out of today's system, increasing now the new, let's say, build applications, using also applications from the market, for example, as a SaaS solution, and making also then the rollout pattern much more easy. So instead of coming in with an application that contains of 600 functions, it's much more easy to say, hey, I want to educate you in a little function that has a dedicated scope. There's maybe 10 or 20 functions into it, and it's much more easier to train and to roll out instead of coming with a big elephant through the door. So working in different ways and also working agile was one thing what we let's say stressed in the last let's say last year also to get this in a very good setup. And I think for the teams it's really good working here also in a different way. Yeah, coming back to this platform a little bit high level again. So the picture I had at the beginning with the 3 layers, reading it from bottom to top. Now you have to read it from left to right. It's always the base or the basic principle. You have the device tier, which is sitting in the plant, the shop floor level, which is physical hardware sitting somewhere. You have then edge tier, which is our OT gateway, technologies, different technologies with the different partners delivering hardware to our facility and plants. And we need technologies, protocols to interact and to get the data out of it. Can be different data, can be streaming data, can be batch data, can be online data, can be every types of data. And we had to build different services, let's say, for this connection. And then finally, you're coming to the point where you sending then this out to cloud, maybe using mainly message broker technology, MQTT technology. And then comes all the data layer, so the abstraction layers, the normalization layers, then also the layers with the APIs to get access to it. But very important is that on the side of a developer, which is basically on the right-hand side in the business application, that he should not have then all the pain and for every application he wants to write to go one more time through all that stress again. He should be able to consume this data and those patterns much more easy. And now you see the 2 patterns at the end. One is what Verena told us about writing some of those applications. That was the focus of the past. And now we want to use same infrastructure patterns, platform patterns to say, okay, our basic principal applications, what we have also to run production and let's say to production planning, production execution, to bring some of those elements exactly to the same ecosystem. Yeah, and this is basic, let's say basically the idea where we start working on. And for example, platform business, and I mean everybody who is in a platform business and running platforms is most of the time also very successful enterprises. And you have then mainly a good reusage of it when you're using those platform patterns. And this is the same what we also want to do beside of risk reduction because you have then much more technologies and latest things for security and all that kind of stuff on the platform level. From the economic benefits, we see that we have continuously increasing costs of our current legacy systems, and that the ratio of having innovation versus the ratio of having support is on a partially unhealthy situation. So what we want to do is to replace it by newer application patterns, so the smaller application patterns where you have much less on support. And with this, we are very confident that we can lower the cost, as you can see it here on the slides, to say, okay, it's possible to get today's application cost down by 20% just by renewal. Or when you see then those overcoming use cases, for example, your supply chain goes down and you need to recalculate and to replan your production. Today it's very hard because you have totally different systems that have to talk to each other, but if you have, let's say, the same data patterns, the same platform patterns, it's much more easier to say, okay, how can I make now a ping if I have no problem with a supplier, tell it directly the guys in production, they can make a new program pattern out of it, they can reorganize themselves, and they can give a feedback back to logistics. And all this, let's say, interactions, this is then powered and, let's say, provided by the platform. Yeah, having this said, I'm going to hand back to Andrea.
Thank you, Thomas. Dankeschön. Thank you. Yeah, supply chain challenges, workforce shortages, raw material prices and availability are all challenges, while manufacturers are intentional and committed to build sustainable products in a sustainable way. So these are just very few reasons for every manufacturer to consider starting or continuing and accelerating their digitalization journey. So thank you very much for sharing with us your experience. And as you said, it's a step-by-step process. You are not making a 5-year plan. You start the journey, you learn, you iterate, you work on shippable increments, you partner up with AWS or with partners. You can see them all here in the expo, or some of them in the expo area. So it's super interesting and a super iterative journey. And thanks for sharing this with us.
You're welcome.
And now for the last very few minutes, AI, ML, and Gen AI are very hot topics these days in the world and in the industry, of course. Could you share with us some of your future plans, how these technologies could be utilized in your company?
Of course. I mean, we talked about some patterns using already AI. So the question when we're talking about Gen AI and what is the next level to take it, what we were thinking right now is even if we have old systems, the logic and what they're doing, it's good because some of the processes are very good, and how it is, let's say, in the systems is very user meaningful. But the way how the coding and the architecture is, maybe not. And so now Gen AI kicks in, and with the question, is it not possible, let's say, to analyze my code, what I have today in my systems, and to say, cannot Gen AI now kick in and can answer me the question, can I keep the logic of the systems? and can't I find a way how to reorganize my code and totally better, let's say, portions, products, architectures, and to say maybe I can group my single applications better, like we had it before on the slides with these little packages. And this is now where we're looking right now in a couple of pilots with you guys. How can we use Q and Bedrock to go into it, making analysis of the code and coming up with better code.
Sounds super interesting. And 5 years ago, I'm sure your answer to this question would have been totally different. So we see how the technology is evolving, and we need to stay tuned all the time. So thank you very much for sharing this information with us. Verena, you want to come back on stage so that we can say goodbye? We wish you all the best for the rest of the reInvent. Have fun, enjoy the music, enjoy the sessions, and come to the expo area. As I said, lots of partners are there. We have also a couple of people here in the room. We have our professional services, if Dennis is here, and Maya, so you can ask questions. I will disappear very quickly. I will do a stage diving just into the Uber, go to the airport, but Verena and Thomas are here if you have some questions for the next couple of minutes. Thank you very much.
Yep. Thanks. And as a final, before we leave the stage, I mean, this is not just a single work of us being here right now on stage. So we want to thank our teams, not being writers here in Vegas, and thank you for the engagement and the hard work of the last years. And yeah, let's keep on moving. Thank you.
Thank you.
Thank you.
Bye.
Bye.